Hello everyone. We are the Department of Commerce CA. Today we are going to discuss about destructors. Introduction. In C++, destructors are a special member function that are automatically called when an object goes out of scope or it's explicitly deleted. A destructor is a special member function that is called when the lifetime of an object ends. The purpose of the destructor is to free the resources that the object may have acquired.
Definition: a destructor is used to destroy the objects that have been created by constructors. Like a constructors, the destructors is the member function whose name is the same as the class but it's preceded by the title.
Syntax. Here's the syntax of destructor. Here is the example of destructors and output. Characteristics of destructors. Name. A destructor has the same name as the class preceded by a tilde symbol. For example, for a class myClass, the destructor would be tilde symbol myClass function. No parameters. Destructors do not take any parameters and cannot be overloaded. Purpose. They are primarily used to free resources that were acquired by the object during its lifetime, such as dynamic memory, file handles, or network connections. Automatic innovation. Destructors are called automatically when an object is destroyed, either when it goes out of scope or it is deleted using the delete operator. Base and derived classes. If a class is derived from a base class, the base class's destructor is called after the derived class destructor. It is essentially to declare the base class destructor as virtual if you expect to delete derived class objects through base class pointers, ensuring
Declaring destructors. Destructors are functions with the same name as class but preceded by a tilde. Several rules govern the declaration of destructors. Don't accept arguments, don't return a value, can't be declared as constant, volatile, or static. However, they can be invoked for the destruction of object declared as constant, volatile, or static. Can be declared as a virtual. Using virtual destructors, you can destroy objects without knowing their type. The correct destructor for the object is invoked using the virtual function mechanism. Destructors can also be declared as pure virtual functions for abstract classes.
Using destructors. Destructors are called when one of the following event occurs. A local automatic object with block scope goes out of the scope. Use delete to deallocate an object allocated using new. Using delete result in undefined behavior. Use delete to deallocate an object allocated using new. Using delete results in undefined behavior. The lifetime of a temporary object ends, a program ends, and global or static object exists. The destructor is explicitly called using the destructor function's fully qualified name. Destructors can freely call class member functions and access class member data. These are two restrictions on the use of destructors. You can take its address. Derived class don't inherit the destructor of their base class.
Order of destruction: when an object goes out of the scope or is deleted, the sequence of events in its complete destruction in as follows. The class's destructor is called and the body of destructed function is executed. Destructors for non-static members objects are called in the reverse order in which they appear in the class declaration. The optional member initialization list used in construction of these members doesn't affect the order of construction or destruction. Destructors for non-virtual base classes are called in reverse order in declaration. Destructors for virtual base classes are called in the reverse order of declaration.
Virtual base classes. Destructions for virtual base classes are called in the reverse order of an appearance in a direct acyclic graphic. Depth first, left to right, post order, traversal. The following figure depicted in the inheritance graphic. To determine the order of destructions of the virtual basis classes of an object type E, the compiler builds a list by applying the following algorithm. Traversal, the graphic left, starting the deepest point in the graphic in case E. Perform leftwards traversal until the nodes had been visited. Note the name of the current nodes. Revisit the previous nodes down and to the left or right to find out whether the node being remembered is an virtual base class. If the remember node is an virtual base class, scan the list, see whether it has been already entered. If it isn't a virtual base classes, ignore it. If the remember nodes isn't yet in the list, add it to the bottom of the list.
Non-virtual base classes. The destructors for non-virtual base classes are called in the reserve order, in which the base classes names are declared. Consider the following classes declaration. Example: class multi-inheritance, public base 1, public base 2. In the preceding example, the destructors for base 2 is called before the destructor for base 1.
Explicit destructor cell. Calling a destructor explicitly is seldom necessary. However, it can be useful to perform cleanup of objects placed at absolute address. These objects are commonly allocated using a user-defined new operator that takes a placement argument. The delete operator can't deallocate this memory because it is not allocated from the other store. For more information, see the new and delete operators. A call to the destructor, however, can perform appropriate cleanup. The notation for explicit calls to destructors shown in the preceding can be used regardless of whether the type defines a destructor. This allows you to make such explicit calls without knowing if a destruction is defined for the type. An explicit call to a destructor when none is defined.
Conclusion: C++ destructors are class members that remove an object. They are named when the class object is no longer in the view. For example, when a method, a program, or a delete variable is called, destructors vary from member function in that they do not accept any arguments and do not return anything. Destructors are also given the same name as their class. Thank you. We are happy to say that the projects are done by Gogala Daksha Sri, Dhanushri, Gayatri, Darshini, Durga Sri, Deepak Raj, Dharni, Darshan, and Digya.